Hey, I hope you're ready to tackle some big bears because we're going to get after it here today. We're cruising through the 2019 Calculus BC test packet. We're ready to tackle question number 5. I think if you're an AB student, you're really going to like Part A. But then after that, Part B and Part C are both BC only topics. In Part B, you're going to see us do some partial fraction work to set or to solve a definite integral. And in Part C, we're going to go crazy on an improper integral, one of our arch nemesis probably. So hopefully we'll be able to squiggle our way through that. Okay, so what does Part A have? So they've introduced us into what they call a family of functions, and that's not terribly unusual for them to throw in some unknown constant or coefficient here. Let's see. And then what they'll do throughout the problem, K will equal one number in Part A or Part B, and then they'll change it and say, well, let's let K equal a different number now in Part C and a different number in Part D, and that continues to evolve throughout the problem. But what we've got here right out of the gates is they said the slope of my tangent line at x equals 0 is going to be 6. So what they're really saying in English is that f prime of 0 is equal to 6. So the derivative evaluated at 0 is going to produce an output of 6. Now the question is, how do I best want to take this derivative? What's the most efficient way possible? I think it's kind of a coin toss here. You can go quotient rule, or you could rewrite the original f of x with a negative exponent and do chain rule. I'm probably going to go with the latter there. And so I'm thinking f of x itself is really, I'm thinking of it as a quantity x squared minus 2x plus k raised to the negative 1. The derivative of that function with the chain rule is going to be negative 1 inside quantity, let's see, raised to the negative 2 multiplied by the derivative of the inside. And if I clean that up just a touch here, I'm going to get a negative quantity 2x minus 2 all over the quantity x squared minus 2x plus k squared. Okay, now it's all going back to this condition right here. Let's say I want to substitute a 0 for that x. Switch colors here real quick. So I know that if I substitute a 0, the answer should be 6. And that's all I did is I plugged in a 0 here, here, here. Real quick mental math, all of those terms basically evaporate. And by the time I cross multiply, I'll get 6k squared equals 2, k squared equals 1/3, and k equals the square root of that, or 1 over radical 3. You don't have to rationalize it. You could, but you're taking on some unnecessary risk right there. And so this is the k value such that the tangent line at x equals 0 would have a slope of 6. Okay, so that's it for the part or the AB type of question. We're going to get into some BC specific material here. And so the first thing we want to do is we want to try to integrate 1 over x squared minus 2x minus 8 with respect to x. Now, right off the cuff, there's no u substitution that's going to bail me out. If I let u equal the denominator, it doesn't lead really anywhere prosperous. So what I'm going to do is I'm going to call a little mini timeout here, and we are going to try to decompose this fraction. So the first thing you're going to do is factor that denominator to make it x minus 4, x plus 2. And we're hoping that it decomposes into some unknown constant over x minus 4 plus a different unknown constant over x plus 2. Now, to solve this for A and to solve for B, I'm going to distribute the LCD throughout both sides, and that's going to leave me with 1 equals A quantity x plus 2 plus B quantity x minus 4. Now, what I like to do from here is I'm going to pick a number that I want to let x equal. So I'm going to let x equal negative 2. Okay, that's going to make 1 equals a times 0 plus b times negative 6. And that's going to tell me that b itself is negative 1/6. Okay. Now, if I do something similar again, and I said, this time I want to let x equal 4, now I'm getting 1 equals a multiplied by 6 plus b multiplied by 0. And a is 1/6. So now I know those two coefficients. Let's go ahead and switch colors one more time. So now the integral from 0 to 1 is really 1/6 over x minus 4 minus 1/6 over x plus 2. The one thing I like to do if the opportunity presents itself is I kind of like to factor that 1/6 out front. And once I factor out the 1/6, now I'm going to integrate and figure out, let's see, my antiderivatives are going to be the natural log of the absolute value of x minus 4 minus the natural log of the absolute value of x plus 2. Wrap that bar up, bounds 0 to 1. I kind of, did the integrating really quick right there. I think what you want to do is in a long form is you'd let u equal this denominator work through a u sub, and you'd get that natural log, and then kind of do a different, start all over, do a u there, and get your ln. I don't know if you've ever seen a problem where these absolute values were going to be more impactful than they are in this particular problem. Those absolute values, which we've always had them there, but never really thought too much about why and this and that. So let's go ahead and substitute our bounds. Substituting a 1 is going to make the natural log of 3 minus the natural log of 3, so those cancel out. Now substituting a 0 is going to make the natural log of 4 minus the natural log of 2. And let's see. In a nutshell, if I distribute that negative and multiply that by 1/6, I can stop right here. I'm okay right there. You're going to see a variety of other answers based on some manipulating that you could do using your natural log properties for sure. I think one other possible answer that I'm seeing in my head right now, because this right here could be written as 2 ln of 2. And so subtracting them is going to make negative ln of 2 over 6 using some log properties. But we're more than okay stopping right here. Okay, let's shimmy on to part C. We're going to see another really challenging question here. And so now you're thinking, wait a minute, I feel like I'm doing the same thing all over again. I'm just integrating with a different k value. So I got x squared minus 2x plus 1. And think about factoring that bar. You might even have had the thought, like, do I have to do partial fractions all over again? Oh my gosh, I didn't factor. Let me erase that. Okay. So that's going to factor really nicely into x minus 1 times another x minus 1. So it's really x minus 1 squared. Now, this was a red flag to me, okay, when they said, hey, evaluate the definite integral or show that it diverges. I don't know if the seeds for improper integrals would have been planted in my mind if they hadn't have kind of given me this gentle nudge right here. They give me kind of planted that seed that, hey, maybe this is improper, because otherwise, why would they be talking about diverging? So think about this graph. There's going to be a vertical asymptote at x equals 1, which is right in between those bounds of 0 to 1. So what I need to do is I need to rewrite this integral as the sum of two smaller integrals. And notice how I'm using 1 as my breakpoint, because that's where the discontinuity lies. All right, and now I need to, using proper notation, I need to rewrite these in terms of a limit. So let's see. This first region, I'm going to say b is approaching 1 from the left, because this particular region lies just to the left of that asymptote. And the integral is from 0 to b, 1 over x minus 1 squared, plus the limit as b approaches 1 from the right now, because if you graph this section, it lies just to the right of that asymptote, from b to 2. And basically, both of these series both of these integrals, I should say, are going to have to converge in order for the final answer to converge. So let's see. Now, to find the antiderivatives of these bars, I'm going to do a u sub here where u equals x minus 1. The derivative of u ends up being the derivative of x, which is nice. And so you end up integrating 1 over u squared, which is going to give you an antiderivative of negative 1 over u. So let's see what we got here. Hopefully I'm not skipping too much here and making this more confusing than it should be. So the antiderivative is negative 1 over the quantity x minus 1, and then I've got bounds from 0 to b. Now notice what happens when I substitute these bounds. Let's see if we can squeeze this bar in here. The limit as b approaches 1 from the left, I'm getting negative 1 over b minus 1 minus negative 1 over 0 minus 1, yada, yada. And notice I really haven't even I haven't even done anything with this integral in a little while, and that's okay, because watch what's happening here. I'm going to try to highlight this nicely here. So this b value right here, for all intents and purposes, since the value of b is approaching 1 from the left, you can assume that this b right here is about 0.999999. Once you subtract 1 from that 0.9999, your denominator is becoming negative 0.000001. So now, if you take -1 and you divide it by negative 0.0001, let's just write that out for the sake of seeing it written. If I took a little sidebar here, -1 divided by negative 0.000001, that answer is actually getting really large, okay, and it's trending towards infinity. So because this term alone by itself doesn't exist, we're going to say that the integral diverges, and I don't even have to worry about evaluating this second integral right here, because it doesn't matter whether he converges or not. If the first integral diverges, the entire thing diverges. So I hope that helps. Hopefully you feel like you're just a tick or more closer to earning that magical 5 on the AP exam. Hopefully you found something that was helpful. I'd ask that you'd hit subscribe below, share this with your friends, and let's keep building this great math community that we've got together.